Welcome to College Nated Engineering with Bongani Gumere. Today we'll be doing Mathematics N4 and we'll be doing differentiation part 2. So it's a continuation of the past video, and then we'll be dealing with problems, and the problems will be based on past papers. So here we have a 2019 November, but before we attempt it, let us read these rules. And these rules, the first one says do not use quotient rule if you are not asked to. So in this question, we were asked to differentiate. They never said use quotient rule to differentiate. So what we should do, it uh, is to analyze and simplify. We have to simplify your question. Then after simplifying, as we simplify, what we don't want to have is fractions. We don't want to have fractions unless if it's a constant. We can allow fractions in the final answer, but when we are busy solving, we don't want fractions. Then you can apply your differentiation. So remember, I said we have to simplify first. Don't use quotient rule, because in the question they said find the derivative in terms of x. They never said that you should use quotient rule. So don't use quotient rule in N4 if you are not asked to use it. The question, if it wants quotient rule, they will ask you. So simplify. So okay, there are these trig identities that you also need to know. They are the most commonly used in N4 differentiation. So sine of 2x is a double angle identity. It gives you 2 sine x multiplied by cos of x, and 1 over sine of x is equal to cosec x. 1 over cos of x, it gives you secant x, right? So okay, let's try to simplify. 3 multiplied by, we have a double angle identity, then we'll have 2 sine of x multiplied by cos of x, then plus 7. We know that the 3 sine x applies to both of these expressions. So we'll have divide by 3 sine of x, then even this side 3 sine of x. We are busy simplifying. We have not yet applied our differentiation. Then we know this, they cancel out, then we'll be left with 2 cos of x. But then there's an interesting something here. Remember, I said that 1 over sine, it gives you cosec x. So here we'll have 7 over 3 cosec of x, right? Then we don't have any fractions. Then it means that we must simplify. Remember, I said we don't want fractions unless if those fractions, they are constant. But variables, we don't want a fraction, or even trigonometric functions, we don't want fractions. Then we are starting to differentiate. Then the derivative, of course, is negative sign. So we'll have negative sine of x, then minus 7 over 3 cosec x multiplied by cot of x. Because of the derivative of cosec x is negative cos x multiplied by cot of x. So we are done with the first example. Let us look on the second example. Now the second example is on 2021 April. So remember, I said we don't want fraction unless if the fraction is a constant. So these ones, we don't want this fraction. We also don't want to see this fraction. We don't want to see this fraction, but this fraction 1 over 2, we can allow it because of it's a constant. But this one, we don't allow it. Although pi it's a constant, it's a number, but it is to the exponent there is 3x. There's a variable, so we don't want to see this fraction. The reason why I'm removing fractions is because of I want you to understand or to get the right answers. So most of the time, students, they become confused when they see something like this. So let's try to simplify first. We know that sine 2x, it's a double angle identity. So we'll have something like 2 sine of x multiplied by cos of x, then plus 1. Remember that the cos of x applies to both of them, then over cos of x, then over cos of x, then plus. Remember that if we have something like this, we just write 1 over 14, then this one come to the side to the power of 7x minus 2x, then plus 1 over 4 pi to the power of 3x minus 2b plus 1 over 2, then ln of x. Yeah, then we still have fractions that we have to remove. Cos x and cos x, they cancel out. Then we'll be left with 2 sine of x, then plus. Remember that 1 over cos of x is equal to sec x, then plus 1 over 14 e to the power of 7x minus 2 to the power of x plus 1 over 4 pi. Then these ones, we are just copying them exactly as they are because of their fine. Okay, now we can start to apply our derivation. Oh, it's gonna be a long one, so let's write it here. Dy over dx is equal to the derivative of cos, no, of sine is cos, so we'll have 2 cos of x plus the derivative of secant x, it's secant x multiplied by tan of x. Then we'll have plus 1 over 14, then multiply by the derivative of f of x. So f of x is 7x, then the derivative will be 7. So then e to the power of 7x, then minus 2 to the power of x, then ln of a. Your a is 2. So we'll say ln of 2. Yeah. Then plus 1 over 4 pi, or 1 over 4 multiplied by 3, because of we multiply by the derivative of f of x, and the derivative is gonna be 3, and the f of x is 3x. So then we'll have pi 3, then we say pi of 3 to the power of x, then ln of pi, right? Then, oh, there's no space. Okay, let's try to rub here. Then after pi, we are coming to this one, then minus 0 plus, remember we are differentiating in terms of x, so anything that is not x, it's considered as 0. Then plus 1 over 2x. Remember that ln of x, the derivative gives you 1 over x, because of at the bottom we put the f of x, and the f of x is x, and at the top we put the derivative of f of x, right? Okay, so we are done. The only thing that's left to do is just to multiply here. Okay, let me not rewrite everything, just let me just change here. Here we'll have 1 over 2 if we multiply, then here we'll have 3 over 4. Yeah, so we are done for this example. Let us go to the third example. You see, I've simplified first, then we got to this answer. So always simplify. Our third question was written in 2020 April. You are asked to differentiate in terms of x. They never said use quotient rule. So remember that rule I told you. But if we analyze, remember I said you must analyze and simplify. But if you look at this question, it's straightforward. There's nothing that needs to be simplified here. Everything is in standard form. Standard form meaning that there's no fraction. Everything is just, yeah, it's just normal. dy over dx, okay, equal to, then we'll say 2 to the power of x, then ln of 2. Remember that we say ln of a, and your a is 2 in this case. If you have watched the previous video, then you'll know what I'm talking about. Then remember I said if we have ln of x or ln of something, you put the f of x or the ln of that something exactly as it is at the bottom, and at the top you put the derivative of it. So we'll have the x, the derivative on top is 1. So because of 1 there, it will be 2 multiplied by x. So we'll have 1 over 2x, then plus. Remember this question I said you just copy exactly as it is and multiply by the derivative. If you have something like this, e to the power of something, 1 over 2 e to the power of x plus 0. Remember differentiating in terms of x. So anything that is not x is constant, so it's 0. Our fourth example was written in 2016 April. Then you are asked to differentiate in terms of x. So let's see. Is there something? Remember I said you analyze and simplify. We're analyzing. We have to simplify here. We have to simplify here. We don't want this fraction. We don't want this fraction also. You know, if you have been doing differentiation for a long time and you're good with it, you can just go straight forward. But because of I want everybody to understand, let's take it step by step. What did I do here? Remember that the rules of logs says that if you have to an exponent, you must multiply it this side, so that's why we put it this side. Then we say minus 3 sec x. Remember what I said about 1 over sine x is equal to cos x. So here we have 1 over cos of x. It will be equal to secant x. Then plus e to the power of x minus 2. Then if it we remove it from the denominator, it will have a negative exponent. So then we can start to differentiate. Why? Because of everything now is in standard form. We don't have fractions of variables, only constants allowed. So now we differentiate. The derivative of cot x only is a negative cosec squared x. But because of we have a negative here, they will multiply and we'll have a positive. So we'll have 2 cosec squared x. Then plus, remember what I said about this one? Just write 6 over x. Then minus 3. The derivative of secant x is secant x multiplied by tan of x. Then plus, remember I said this type of problem where you have e to the power of something, just write it exactly as it is and multiply by the derivative. Then we'll have minus plus, because of negative 1 times negative 2, positive 2. Then x minus 2. Then our answer is correct. But remember, we don't want to have negative exponent, so we'll have 2 over x minus x squared. Yes, but let me just write it so that everybody can understand what I'm talking about. We'll have something like this. We've come to the end of the video. Thank you for watching, and may God bless you. Like the video, share, comment. Yeah, let me know about the video. How was it? Yeah, I'll put my contact on the screen, so you can contact me anytime you have problems related to this video or related to differentiation and 4. Yeah, that's it. My name is Bongani Gumede. Thank you for watching. Shop.